right. Good morning, good evening, good afternoon to you all. I'm Gloria from our events team, and I'm here with the team at LUKSO here for another office hour. So hopefully you brought your questions. If you do have, before we get started, I want to take care of housekeeping. First and foremost, this session's being recorded. So you'll find this session and all the other sessions under the LUKSO playlist on the Get Coin Media YouTube channel. Also, if you do have questions, there's two places you can drop your questions. One is the chat and the other is a Q&A. Both of them get monitored, so feel free to take a look at that and I'll make sure your questions get answered. And last but not least, in the chat, please say hi, let us know where you're watching from and what you're working on. It's a great way for us to get to know y'all and a good way for y'all to get to know each other. With that, I'll hand it over to the LUKSO team and you can go ahead and get started.
Hey, thanks a lot, Gloria. Hey everyone, welcome to this office hours we've got. So I guess we can basically just get started, I think. So there's a couple of questions which we'll address first, which were gathered beforehand, and then we can go to some live questions, I guess. So the first one we had, the question was around, it was around deploying a universal profile through a CLI. So the question said, has anyone developed a CLI to deploy universal profiles? And they need to create a universal profile without using the browser or browser extension. So the answer to that is we actually have a library, LSP factory. And if you can use that library in a backend service or just run it in a script locally, that will do everything you need to deploy a universal profile. There's no like dedicated CLI, which we have, which you can download, but the library you can use and import and deploy universal profiles really easily. So the question asked about storing the public or private key. So if you were going to deploy it, you would store the private key in some secret somewhere. Otherwise, you can just paste it into your code, and then that private key is going to be the one which deploys your universal profile. And so that key will need to have some gas. But LSP Factory will do all the work to deploy that universal profile for you. And also you can do the same thing with token contracts and NFT contracts as well, LSP 7 and 8. So hope that answers that. Second question is...
Yeah, we have a question about key value tampering on the universal profile.
The question was about basically if you have a universal profile and you want to, as an application, write some data on the universal profile, how can you stop someone from overwriting it? And the answer is you can use the key manager. So for each key, every controller key can have some permissions on the universal profile. So you can restrict certain keys to do certain things. So some keys can have a set data permission, which should allow them to be able to write into the universal profile key value store. Or some can transfer value or transfer ownership. So you can have like this granulated permission system for different keys. But however, any key which has the permissions to set data will be able to write to the contract. So I think for this particular use case they were asking about, it maybe seemed like they would maybe want to store, they're basically looking to store some tag for a universal profile. So an application could tag a universal profile, and they didn't want the owner of the universal profile to be able to overwrite it. The problem is that the owner of the universal profile can always overwrite any key if they have the right permissions to do so. So you'd be better for that use case storing the tag in some other contract and mapping between the universal profile address and the tag you have, because the owner will always be able to update their own keys in their own universal profile contract.
Yeah, so the idea would be to have more of this as the universal profile stores reference to the tag, and the tag, as Callum explained, would be stored into another contract. So the profile owner can edit the reference under this key, but it cannot edit the tag itself. That would be a one way of preventing the tampering, but first one way, but you could be thinking of it. I don't know if I answered the question. Whoever asked this, if he's on the channel.
Yeah, but any key which is about a universal profile, which you don't want the universal profile to be able to change, you would have to store somewhere else, not on the universal profile itself, because they can update it themselves. Yeah, I think that does. So, I mean, those are the two questions which we had asked previously. So I guess we can open it up if anyone wants to fire some questions in the Q&A. We can.
Yeah, I think on this, just to add on the point two, what's worth mentioning is that in like if you do this form of permissioning around specific key, it really depends on the use case and how it's implemented. But in general, if you allow an address to set data, or permission set data, it's very likely that you will use that in combination with a set of allowed data keys. So like unless you really trust the controller that you are granting permission to, so that you will allow this address to set any data in the contract storage, and it's okay if really you trust the address. But in general, what's recommended is that if you have of addresses, whether it's contracts, protocols, or dApps, you will allow if you will allow these addresses to set data on the universal profile, is very recommended. I would say that I would highly recommend that you restrict this address to set a specific set of allowed data keys, so that you just give them like a sort of context. You only restrict this address to set the data keys that are relevant to them. If it's a dApp, to the data key relevant to the dApp, or like if it's like a protocol, just the data key relevant to these, like because you don't want these dApps or this protocol to be able to edit over information. So that's what I would recommend in general. Just when you give permission, set data to an address, in combination, always restrict the data keys that you want this address to operate on.
Yeah, and the key will only be able to update that specific key.
Yeah. Okay, we have more questions in the Q&A section.
Cool. Yeah, so the first one about the browser extension. So I said the Chrome extension, it actually works on Firefox as well, just to flag. Yeah, is there any way to tell if the injected Ethereum provider is for the browser extension or for MetaMask? Yeah, so there's not a property on the Ethereum provider like MetaMask is MetaMask, I believe. So you could tell if it's you can use that to check if it's a MetaMask one. The universal profile browser extension doesn't have like an equivalent key, and the idea was just to keep it like as lightweight and generic as possible. But what you could do is the address which is you're going to get when you request addresses using your RPC methods is going to be the address of a smart contract, whereas MetaMask is going to be the address of a controller, an EOA controller key. So the universal profile will have code stored at that. So what you could do is make a request to the blockchain to check whether there's any code at the address. And if there is code at the address, then it's a smart contract and it's not an EOA, which would indicate that it was the universal profile browser extension and not MetaMask. So that's another way you could do it.
Then we have what are the best practices to fetch data from IPFS server? Are there any dedicated servers which works best with LUKSO?
So Best practices? No, I mean, like LUKSO as a network isn't restricted to any particular IPFS server or IPFS gateway. It should work with any of them, and the IPFS service should all sync up. Like you can store, you can store your metadata wherever you like, including your own private server if you wanted to. There's not really any best practices. I think IPFS is so it means if you shut down your local running server, then it's not going to disappear. So it means people can always access it, but there's not like a specific server you should use. We do have an IPFS cluster of our own, which we use for our own development purposes. You can use it too. The address is in the Discord. You can find it. So you can use this one, but any IPFS server should end up with the same result. So hope that answers that. So the third question.
Yeah, so I think the next two questions are linked together.
Okay, two-parter.
Yeah, so for the UP extension, I can only get one, granted permission to third parties, or two, executing relay transaction to work if the user exports their private key and pastes it manually into the DApp. Can this be done without having the user export their private key? If it's not possible yet, how does the team suggest we implement these features for the hackathon? So we can probably answer both of us your suggestion, Callum. I would say so like in the guides, we do that for simplicity because we want to just explain the essential of how it is to interact with the EP in JavaScript and Node.js. But I would say like you can use the standard ways to hide sensitive information in the backend application. So one way, for instance, is to have the private key stored in the .env file, and you fetch your private key from the .env file into your backend script. That's one way that I would be thinking of. But yeah, in the guide we do that for simplicity, basically to not hide. We don't want us to focus on how to set up a project with .env, like a .env package. For instance, we just want to show exactly how it works, not to really go to the essential. I don't know if you have a suggestion, Kevin, on your end.
Yeah. So if you're writing a front end like a D app, you shouldn't you don't want your users, you don't want them to have to copy and paste a private key into the front end, because that's really insecure, because that's going to be sending over traffic and get intercepted and things. So the universal profile extension should handle this for you. The executing relay call transactions, the browser extension actually already does this inside. So when you're signing a transaction, by default, when you confirm a transaction in the browser extension, it will be sent to a relay service. So it's already doing that for you. We will have a feature to add your own custom relay service. So you can add your own custom relay service URL in the browser extension, and that will be released soon. So if you're building a relay service, then you can paste that in and do it that way. But the browser extension actually does the job of preparing the relayed call transaction for you. So you don't need to do that on your on the client side. The other one's granting permissions to third parties. So the granting permissions should work because that's just a set data transaction, because you're just setting the LSP6 permission keys for that particular address. That can also be done within the browser extension. Like there's a tab which is controller keys, and you can oh no, it can't actually. Sorry, I think you can remove them, but you basically need to send a set data transaction which updates that key, and it's the LSP6 keys which you want to update, and also updating the permissions array and the permissions array length. So all three of those things. So possibly you were missing one of those. So maybe you were updating the permission, but not updating the array, which would mean that if you're using ERC75JS to decode that, then it might not be showing up. So possibly it might be that which is going wrong. So you need to make sure you're updating the permission itself for the address, the array, add the address into the array, and also update the array length as well.
Yeah, so on this guide, we noticed that there is one of this element missing on the guide to give permission to third party. So like the basically like the guide so far give permission to an address, but it's missing setting the data keys to add the address into the array of controller addresses. By controller addresses, I mean addresses that have permission. So we will provide a fix on the guide soon to add this extra two data keys to set. So yeah, when you grant permission, like really if you want the full flow is you have to set the data key for giving the permission to the new third party address. Then you have to increase the address permission array, meaning like you have to specify if there was 5 address permission in the array length for address permission was 5, and you have to increment it to 6, and then you have to add the address in the additional index. So there's literally 3 keys to set. So we will do a fix on that on the guide.
You can find the specification of this in LSP6 for more detail.
Yeah. There's another question from David Catalin. Updating a profile setting the description from universal profile extension is overriding the previous saved data. Can the PR be open for this issue? I'm not sure I understand the question properly.
I guess it's saying that so when he updates the description in the universal profile, it's overwriting all the existing metadata, which would be a bug. We actually have an issue tracker repository, so you can create an issue in that, and the team will review those issues and go through and take tasks from that and identify bugs. I will post the link to that in the chat. So yeah, if you have bugs like this that you identify, open an issue here, and then we can review them there.
The next question is about, from my understanding, the UP browser extension depends on the factory contract to deploy universal profile for its user. Where can I find the source for this factory contract?
Sorry, just let me read the question. Nice.
I think it's a create 2 factory, right?
Yeah, it's create 2 factory. So good question and good investigation. So so the browser extension, when it creates the universal profiles, it creates them from our relay service. So the browser extension sends a message to the relay service to tell it to deploy the universal profile, and the relayer deploys the universal profile. This factory contract is the create 2 factory. So this is used so we can predict the address of the universal profile before it's deployed, because within the browser extension, when you open it up and create a new universal profile, you can select your identical, which is like the little image. It's like kind of splodgy colors. And the idea, each one of those identicons corresponds to a different address, and you'll see you can select the identicon and the address changes with it. And the way that works is by deploying it via the create 2 factory. And create 2, Jean can maybe elaborate further than I can on this, but the create 2 is an opcode in Solidity which allows you to deploy a contract at a predetermined address. So basically, that's what this contract is doing. Is it's just deploying the bytecode at a specific address, so we know in advance what that address is going to be, so that you can select it in advance.
Yes, I posted a comment on the question with a link to the contract that is being used. Cool. Solidity contract. It's exactly what Helen explained. It's just a factory that you provide the bytecode of a contract, so the bytecode that includes the constructor arguments, and this factory basically just predict the address of a universal profile and then deploys it. It does use under the hood the create2 opcode. If you look at the contract, you will see the assembly block that does that. It just it basically specify like an amount to deploy the contract. It grabs the bytecode from the EVM memory, and then it loads that back with a salt added, and it deploys the contract. So it's just a bit for the like underlying instruction. But yeah, that's literally just a basic factory that does that. Yeah. What is the role of a data parameter in the mint function? Param data, additional data in the caller, but the caller once included in the emitted event and sending the hooks to from. What data exactly should be added here? So this is really up to you. It's basically when you mint or when you transfer, you always have this extra field where you can provide additional data. The data is like it can be something that is relevant to your application, because, for instance, you have custom contract implementation that want to read this data field. So I can give an example. Like a dummy example, if I send an NFT to, if I mint an NFT for column address, I could say the data field received NFT and NFT, the reference of an NFT, and any specific information, and Calum could have an interface that reads this event and basically decode this data field. So if it's not relevant to you, you don't add anything. If you want to add some specific custom information, you can add it in this extra field. So this data field will then be forwarded to, it will be forwarded to the universal receiver function, and in turn the universal receiver delegate contract of your universal profile. That's basically it. You can, if you have any extra question on that, feel free to comment in the Q&A. But yeah, hope it answers the question.
So I'm muted. It's basically some you pass some bytecode that you want to be executed while you mint.
Yeah, that could be also that could actually be also a payload. You could have a custom logic that you have a universal receiver delegate, then that do another external call and forward this data, because let's say, I don't know, like let's say if you receive a specific type of token, you want something in particular to be executed, so you could ABI encode a function call in a contract and pass that into this data field and have a custom LSP1 delegate that executes that. That's totally feasible. So that could be information for reading, for just notification, but for execution as well, as Kevin mentioned. That's actually relevant.
Yeah, I think like that kind of use case is maybe more on the advanced sides. And for most cases, like just when you're minting, put 0x to put null bytecode. Because the contract still expects so you put null in like bytes, so 0x, just so it still it wants you to pass the parameter, and you can't just leave it blank. Which is something to watch. So next question, I think, is how do I restrict an unwanted party from arbitrarily listing me as the creator of an asset? So that's an interesting question. I think the thing is, the creator standard, I believe, is LSP4, the digital asset metadata. That metadata is stored on the or at least it's linked to from the contract itself. So from the like the asset contract itself. So there's not really much you could do from that asset just putting in your address, because it's, you know, you can't stop anyone from using that address on the whole blockchain. So it would show there. I mean, I guess the difference would be what you could do is you could potentially like remove all references from that token from your universal profile. So if you didn't want that universal profile to show up on your side, you could remove it from your owned assets array and things like this, so that it wouldn't show up as part of your portfolio or anything like that. But because the creator is on the digital asset side, you couldn't really stop them doing that. I guess as well in the future, when we have more work into like the reputation side of things as well, that could come into it and be a way of like like saying that you don't accept this, and it's not a reputable digital asset because it's got fake creators. Yeah, that's maybe how we deal with that in the future as well.
Yeah, I would also add, I posted a link. I think Yamen is on the call if you want to add anything else, Yamen, on this point. But basically, so there is this flow of, so Yamen has kind of explained the LSP4 creator. So let's imagine, let's try to do an example. Let's imagine we have an NFT collection represented as an LSP8 contract, and we on this collection we have because the LSP8 is based on ERC725Y, it has the entry LSP4 creators. So only the owner of the LSP8 contract can set this data key. So this is the first thing. So only the owner can basically set this LSP4 creator array. So you could do that, and as I posted in the link, you can also on UUP set the data key LSP12 issue assets for cross-referencing and verifying that you are actually the actual creator of the asset. Now you can, so if you want to guarantee, like if you want to basically not being tampered with, you will not set under your LSP12 issued assets the address of a LSP8 NFT contract, if that makes sense. So that's one way to restrict that, to make sure that what the information that you are providing about if you have a creator is authentic proof, is the cross-reference. The second thing is, let's imagine you are your universal profile deployed an LSP8 NFT contract. So your universal profile is the owner of the LSP8 contract. So you as a UP can set this data on the LSP8. If you want to, if you will have an address that has a permission that has basically this permission, you also want to do the same. You could have a key manager linked to the LSP8 first as an owner, and you could only restrict certain addresses to set these data. You could restrict only yourself. This is more advanced usage. It's something we will be exploring in the future, having token NFT contract owned by the key manager. But I would say for now, the first way is to do this cross-referencing between LSP4 and LSP12. Yeah. Hope that answered your question.
Yeah, exactly.
Yeah. Thanks, Yamen. Okay. Maybe we have more questions in the Build UP channel, no?
No, I guess we can.
Okay, we have two questions. After successful deployment of LSP8 contract and muted the contract on Block Explorer, we see 0 token.
Yeah. So wait, is this? Yeah, so when you deploy the contract, there are no tokens there because all you've done is you've deployed the initial contract where the tokens will later be minted from. So to show a balance, if you wanted it to show 1 token or 2 tokens, you would actually need to then mint the tokens. So deploying it it just gets it ready, so gets the contract there from which you could mint, but afterwards you then need to actually mint to be able to create some tokens. Otherwise, it's just a token contract with no tokens there.
Okay, he's replying, we have minted 3 tokens to the contract.
Okay, and I guess they sent them to the smart contract. I mean, I'm not too sure.
Did you use the browser? Maybe wondering if he used the browser extension or how he created the UP, maybe.
What you can do to verify is you can actually send a request to the token contract and check, like get the balance of this address, and then you can check. Sometimes there's differences on the block explorer. It's not always 100% up to date because it's just a UI. So if you want to verify, you can send it. Send the request to the LSP8 contract to get the balance of the address, and then you can check that the balance is correct.
I would suggest if the issue persists, you can open an issue on the GitHub. Do we have the link of issue tracker actually?
Yeah, I sent it in the chat. So if you find things which you think are problems which we need to fix, like please create an issue and we'll look into it.
Maybe what I'm thinking as well, maybe the problem you're having is that when you leak on, so you say you deployed the LSP8 contract and then you mint it on the, I think I understand a bit better, and then you minted some NFT, but then when you go into the block explorer of the, when you you paste the address of the UP on the block explorer under the token field, there is nothing listed. One of the reasons probably is that the block explorer doesn't support indexing so far for LSP7 and LSP8. It probably supports indexing for ERC20, ERC71, because I remember I tried in the past deploying ERC20 and ERC71 and transferring to UPs, and they are listed. For now, it's probably not showing because the L16 block explorer doesn't index these LSP8 and LSP7 token NFT contract because it's like its new standards. We could look in the future at adding that. I think that's if I understand properly the issue. What you can do as an alternative to make sure that you actually own the NFT is you can look at the, I'm going to send the link, you can look at the LSP5 received assets on your universal profile. So when tokens on NFT are sent to your universal profile, we already for architecture, as we explained in the part 2 of the standards workshop. These assets are registered by the LSP1 contract into the universal profile storage. So you can retrieve the address of these assets and the LSP5 received assets, data keys into the value store. I'm going to put a link in your question. I don't know if it's exactly that, but I believe this is why, I'm pretty sure this is why it's not showing on the Block Explorer. Block Explorer show only ERC20 and 71.
Yeah. So
right, for now, yeah.
Yeah, there was also another good suggestion. You can use the example DApp we have, which is you can deploy LSP8 tokens from there, but it also shows you your balance. And the way that DApp works is it, as Jean described, it's pulling the LSP5 received assets. And so you can see your portfolio and check. And so if you have your universal profile in the browser extension, if you deployed it through there, then you can just log into that DApp and check your portfolio. And that DApp under the hood is querying the LSP5 array. So it's showing you what's in there.
Yeah, basically, it's actually so this question about why it's not showing. It's actually it's actually the current problem of the token and NFT standards. If you want to have, if you think about it, like a service like EtherScan, what it does is that it scans all the ERC20 and ERC31 contracts that it knows, and it scans all of them for your address, checking if you have any balance. So it's like an inside-out. It's like a lookup that goes from your address to different type of token contract. So it takes your address, it goes through all the token and NFT contracts that it knows on the network, and it searches the balance for your address. And the problem is that this relies on the services of EtherScan, that the API is working and running to index all of these tokens. And what LSP5 enables is to do the opposite. Instead of doing this inside-out process, so scanning through like a very large amount of token addresses, it goes the other way, because we register the asset on the UP. Then if you want to know the assets that you own, you look up inside the UP instead of relying on the third-party service. So that's why basically it could be possible to implement a mechanism to index the LSP8 and LSP7 on the Block Scout instance. But I would say the easiest way is really to look at the LSP5 received assets. And you can do that very easily with I really highly recommend, if you want to look for these data keys, to use ERC75JS. It's extremely easy to do that. It's literally, it will take you probably around 5 to 10 lines of code to create the data key and to instantiate the library and to look up for LSP5 with received asset data key. So if you can do that, and instantiate the ERC75JS library and then look up the LSP5 received assets array, and you will get everything back in a very nicely formatted way. And it's very convenient for that.
Yeah, and this is what's cool about universal profiles is this. Yeah, as you said, this issue with it not appearing on Block Scout is because that's just how it works in the old world, right? And when you have MetaMask or something like that, you have no idea what tokens you own unless you go to some index service or something like that who's keeping track of all the tokens for you. Whereas now with universal profiles, you just query the universal profile directly, and you get the answer.
Yeah. So Jeff Young on the same topic, and we are now on LSP5. I mean, if you have any, if you know feedback on that, but Jeff Young is asking, if I transfer an asset from a UP to a vault, does the assets get moved from LSP5 in the UP to LSP5 in the vault? If so first part of the question. Second part of the question, if so, then if I want to retrieve a full list of assets associated with the UP, do I then need to iterate through vaulted assets? Yeah, that's a very good question. And yes, indeed, when you double check with Yamen, but yeah, if you transfer an asset from from a UP to a vault, it would be removed from the list. Like, so the vault has its own universal receiver delegate linked to it. So when you do a transfer, when you call the token or the token contract, and you say from my IP address to the vault address, is going to be these hooks, notify token sender and notify token receiver, that are going to be happening. And basically, they are going to, these two methods will be called, and they will call the universal receiver on each contract, on the UP, on the vault. And what will happen is that on the UP side, it's gonna delete it's gonna not delete, but it's gonna remove from the LSP5 received asset array the asset. On the vault side, it's gonna register it, add it. So yeah, this is what will happen when you do this transfer. And yeah, if you want to list to know the full list of assets that you own, you should also look individually on each vault. Yeah, because the vault is a contract that is the sole owner of this asset as well. So yeah, you should look at the asset that you own in UP and the asset that you own on this vault. The reason is that each vault can be used for a specific context, so that's why you have to look through each of them. Yeah, I hope that answered the question. I will see if I can provide a small figure as a reference. Yeah, we have a great question. Yeah, I'm just going to share that. So I'm just sharing the picture as a comment to your question, Jeff Young. If you look at the list of figures here, you will see the second figure. There is notify token sender, notify token receiver, and you can think of on the left is your UP in pink, and on the right, instead of another UP, it will be a vault. Because the same principle will happen. The universal receiver function will call the universal receiver delegate of each of these linked to each of these contracts, and then the universal receiver delegate will call back the other key manager and then re-register the asset, like update the assets, the list of assets. Yeah, so that's what will happen. So yeah, you have to look into the LSP5 receive asset of the European vault. Cool.
Nice.
Nice. Yeah.
Give you some time to think of some more questions.
Yeah. Yeah, Catalin posted the link of sample DApp, I think, which you were mentioning, Karu.
Yeah. So you can use this link to deploy tokens and check your portfolio and mint tokens. And also you can check the source code of this app as well. It's on the GitHub if you want to see how it works and what's going on. But basically, like all of the queries and stuff is very simple. It's all going through ERC75.js, and then just get the addresses that way. And for deployments, the deployments are all using LSP Factory as well.
Yeah, I'm going to quickly share my screen just to highlight something. Let me see. Sometimes maybe. Can you see the docs here, Kalu? You see the doc page?
I can.
Okay, yeah. So yeah, it's just to add. So if you go on doc.lukso.tech, so just to give you from the starting point, you go on tools. If you go on ERC75.js and getting started, you can see some basic example of how you would use the library. Yeah, the reason I show that is that the library, when it comes to things like fetching information about the UP, retrieving data related to universal profile, knowing the assets that you own, knowing all votes that you own, knowing the address of your universal research delegate. Really, ERC75.js makes this very much easier, because otherwise, especially and in particular for the things like the data keys that are type mappings or arrays, because if you have to do that at a lower level, you have to look through every single key. And this is an example of the usage. You can use, so you just see instantiate ERC75.js, basically with the address of, this will be the address of a universal profile. This is the L16 endpoint, your IPFS gateway. And once you have that, you can literally do things like for instance, for information that is meaningful, like LSP3 profile, it will give you the whole object, and you can use that very easily. So you will get the IPFS URL of your LSP3 profile metadata with all your details. And here you can even do fetch data. Here you can see it will get the whole object and the whole. And you can, and initially I was mentioning that because like someone asked about LSP5 received assets. ERC75 makes that very easy. Here, like here, the example is for LSP12, but basically, if you retrieve the data key and then you pass with a parameter like that, you literally obtain the list of addresses. You basically obtain the list of addresses, so it makes things much easier to retrieve the list of issued or received assets. It's convenient, really convenient for retrieving that. It's an extra information to mention, I think.
Yeah, that's great. Good to see how it works. I guess there's no more questions for 15 minutes or so, so maybe we can wrap it up.
Yep.
And give you all a final chance.
Yeah, is there anything from that you guys want to clarify, or in particular Nathan, Jeff, regarding the question, or Peter? If there's any extra point, just feel free to add in the Q&A.
And if you think of something after, we're in the Discord, so ask the questions there and we can continue chatting.
Super.
Cool. Glad it was helpful.
All right, awesome. I can go ahead and close the session.
Sure, sounds good. Thank you all for joining. Thanks for the questions.
Yeah,
and see you in the Discord.
All right, thank you, everyone.
Thank you.
Bye-bye.
Bye.